To example 11 from our 3.4 notes. Here we're asked to find a polynomial of degree 7. We're given some information about the end behavior. It has left behavior up. So that means the left side is going to shoot up. And it has a degree 7. Vertical stretch 4. And then we have some information about the solutions here. So let's look at the end behavior first. If it's degree 7, that's odd. That means the ends will go in opposite directions. So if the left behavior is up, that means that the right behavior is going to be down. This graph looks like negative x cubed, which will have left behavior up and right behavior down. So we know we have a negative leading coefficient. That's what we can tell. That's what we can determine from that. A vertical stretch of 4. That means that the absolute value of the leading coefficient is 4. If the absolute value of the leading coefficient is 4 and it's a negative leading coefficient, that means our polynomial function, if we begin to write it as f of x, is going to have a equal to negative 4. Let's move on to the zeros, or the solutions. Each solution is going to give us a factor. So if we have a solution at x equals 2, that's going to give us a factor of x minus the solution, or x minus 2. With multiplicity 3, that means we're going to raise this factor x minus 2 to the third power. If we have a solution at I, that means we have a factor of x minus I. But remembering that imaginary solutions always come in pairs, we know that negative I is also a solution. Which means we'll have another factor of x minus negative I. Moving on, we see that we have a solution at 1 minus 5i, so that means we have the factor of x minus 1 minus 5i. And for the same reason that negative I is a solution, we'll have that 1 plus 5i is also a solution. So I'm going to have that second zero. X minus 1 plus 5i is going to be a solution. And this is about the point that we got to in class, so we did it quickly, so I wanted to do that part again. This is the function, but we're told to leave our answer as a polynomial in factored form with linear and quadratic factors. So we can't have any imaginary terms. So we have to expand this to the point where we no longer have these factors with I in them. So I'm going to begin expanding this polynomial. So we have negative 4, x minus 2 cubed. Those are set. And now I'm going to expand this part. So I'm going to have x minus I times x plus I. I recognize that as a difference of squares pattern. So it's going to be x squared minus I squared. I squared is equal to negative 1, so it's x squared minus negative 1. So it's going to be x squared plus 1. And I can stop expanding at that point. I'll bring these other factors down. Negative 4 times x minus 2 cubed. And then let's work over here with these factors. I'm going to first distribute the negative. So I'm going to have x minus 1 plus 5i, and then x minus 1 minus 5i. I'm going to group these so it's a little easier to expand it. So I'm going to group the x minus 1s in each of these factors. And then I can see this is a difference of squares pattern. So I have x minus 1 plus 5i and x minus 1 minus 5i. So that is going to expand as x minus 1 squared minus 5i squared. And so that's going to be x minus 1 squared is x squared minus 2x plus 1 minus 25i squared. Remembering that I squared is negative 1. This is going to give me x squared minus 2x plus 1 plus 25, or x squared minus 2x plus 26. I'll bring down the x squared plus 1 and the x minus 2 cubed and the negative 4. And that is our function. I'd also like to show you a clever way that we can find these factors if you don't like expanding the factors with the imaginary terms as we did here with x minus I times x plus I. This is the clever way. So what we can do is we can think about what happens when we get those solutions. So we can say that we know that plus or minus I are solutions. So I'm just going to write that down. We finished the problem here. So this is alternate way to find the quadratic factors without the imaginary terms. Okay, so what we can say is I know that plus or minus I are solutions. So I know that I could start with x equals plus or minus I. Then I could say that's x equals plus or minus the square root of negative 1. And then I could square both sides. So that would give me x squared equals negative 1. And I bring the negative 1 to the other side, and I have x squared plus 1, which is the same factor that I got when I expanded x minus I and x plus I. Let's do the same thing over here. We know that we had x equals 1 plus or minus 5i. Those were our solutions. If we look back up here, we had 1 minus 5i and 1 plus 5i. So doing the same technique here, I can say that x equals 1 plus or minus 5 times the square root of negative 1. Then I would bring this 1 to the other side, so x minus 1 equals plus or minus 5 times the square root of negative 1. And then I would go ahead and square both sides. So I'd have x minus 1 squared equals plus or minus 5 times the square root of negative 1. So I'd have x squared minus 2x plus 1 equals 25 times negative 1, or negative 25. Bringing the negative 25 to the left-hand side, I'd have x squared minus 2x plus 26 as a factor. And that is the same factor that we got right here by doing the expansion. So you can find those quadratic factors by either method, either doing x minus the 0 or thinking about what would happen if you solved a quadratic equation and then reversing those steps.